Good morning, students. Today we will start with univariate statistics. Till now in chapter 4, we have discussed what kind of the data we have, how to make the data usable, and then descriptive analysis, and along with that graphic aids. Because till then you have not done sort of any analysis. Now with univariate analysis, we have just discussed how to test a hypothesis in our last presentation, and now we'll be starting with univariate statistics. Univariate statistics, this needs test of statistical significance and hypothesis testing one variable at a time. Just with the next slide, we'll understand why we are saying hypothesis testing one variable at a time. Choosing the appropriate statistical technique. How would you choose? There are numerous statistical techniques available. This is not just univariate, bivariate, and multivariate. There are so many techniques inside them as well. So, number one, type of question to be answered. What kind of the question you are going to answer through your research studies is very important to decide what kind of the analysis you will be going through, right? A kind of question, for example, whether you want to check the relationship of two variables, or you want to check the difference between some categories of people. For example, you want to know whether the opinion of men and women different on something or not, or you might check with age their thinking ability changes or not, with age their way of seeing some things differs or not. These are the things we'll be checking, sort of the difference between the categories. And to check the difference, we always go with either t-test or ANOVA. And then there are so many other things also, on the basis of which you will be deciding whether you will be going for t-test, ANOVA, or some known parametric test. Then number of variables you have. If you have just one variable for the study, you will be going for univariate statistic. Univariate means you are talking about one variable at a time. Then if you have got two variables, you will be going for bivariate statistics. If you have more than two variables in the study, you will be going for multivariate analysis. So that means univariate, bivariate, and multivariate is just related to number of variables you have in the study, right? So if you have one variable, that is univariate. Single variable, bivariate means you will be having two variables in the study, you will be having two variables at hand to analyze. And then if you have got more than two variables, you will be going with multivariate analysis. That's it. Other things would be decided with the help of other type of questions to be answered, and scale of measurement. What kind of the measurement scale you have used to collect the data. Type of questions we have already discussed, but what kind of the question you are looking for, whether it is a kind of difference or the associations you are talking about. On the basis of that, you will decide which kind of the test you are going to do. And that also would be decided on the basis of scale of measurement as well. Like what kind of the data you have to analyze. For example, whether you are going with parametric statistics or non-parametric statistics. Parametric statistics basically are those which include metric data. For example, data collected through ratio scales. And non-parametric statistics would be used where you have collected data with the help of either nominal or ordinal scales, right? Nominal and ordinal scales consist of low amount of low you can say details of the data, but whereas parametric statistics contains all the required details of the data for the analysis. That is why when we talk about the kind of scale used for the study, this is very important to see whether you have parametric data in hand or non-parametric. So if you have ratio scale data, then you will be going for parametric statistics. That means t-test, ANOVA, correlation, regression, such analysis. But if you have non-parametric data, that means if you have collected data with the help of ordinal or nominal scale, you will be going with non-parametric statistics. For example, there are so many, Mann-Whitney, Kruskal-Wallis, and so many others, right? So Here we'll be talking about which kind of the statistics we are going to use. So we use three parameters. Number one, number of questions to be answered. Number two, number of variables we have in hand, one, two, or more than two. Then kind of data we have. What kind of the scale we have used for measurement, right? Parametric or non-parametric. So these three things would majorly decide which one of the tool, which one of the analysis you will be using for your study. Let us start with t-distribution. T-distribution is generally used like when your data is symmetrically arranged. It gives you a bell-shaped distribution, like we discussed in our last presentation, how the sample would be distributed, right? If it shapes, it is bell-shaped, then you will be going with t-distribution. And another condition is mean of 0 and a unit standard deviation. If data has 0 mean and 1 standard deviation, then also it qualifies for t-distribution. Then shape influenced by degrees of freedom. We will just discuss what degree of freedom is. Degrees of freedom basically would be calculated with the help of two things. One is observation and then number of constraints. You'll be taking total number of observations minus number of constraints. That is your degree of freedom. And this is very helpful while deciding to go for t-test. What kind of the test you are going through would be decided by so many parameters, and this is one of them. One more thing here is, if you have smaller sample size, then only you will be going for t-test. Otherwise you can even go with z-test. T-test and z-test are almost equivalent if your sample size is greater than 30 units. Yes, confidence interval estimate using the t-distribution. Confidence interval, you must have in your mind what confidence interval is. We'll be calculating upper limit and lower limit with the help of given formulas here. You will have to memorize these formulas, but you will really have to, because these are really helping in writing normal your subjective questions, and if a numerical comes, then also you will be needing this formula. Here is the abbreviations are given, like mu is equal to x bar plus minus TCL and S x bar. We'll explain them in next slide. Mu is your population mean. We have already discussed it so many times. Then x bar is your sample mean. TCL means critical value of T at a specified confidence interval. The confidence interval you have mentioned in the starting, whether it would be 0.05 or 0.01, right? For this, tables are available at the end of your books. Then SX bar is standard error of the mean, and whereas S is standard deviation, sample standard deviation, and n is your sample size. With the help of these abbreviation, you can learn these formulas and calculate the required things when it comes to t distribution. You might be given mean at some times, you might be asked to calculate the mean only. So there are so many things you can calculate with the help of this formula, and you can actually apply t distribution whenever it is required. You can have a look at this example. We have discussed one example in our previous presentation. From there only we have taken all the values. If you remember, upper limit and lower limits, and n was equal to 17. With the help of this, you can actually calculate upper limit and lower limit for t distribution again, and you can apply them with the help of the normal bell-shaped distribution. Now, hypothesis test using the t-distribution. How would you check the hypothesis using t-distribution? Let us discuss it with the help of one example. Suppose that a production manager believes the average number of defective assemblies each day to be 20. That means this is manager's belief of those items to be 20. The factory records the number of defective assemblies for each of the 25 days. It was opened in a given month. The mean of these items calculated to be 22, and the standard deviation S is to be 5. right? So we have all the values with us. We just need to put these values in the formula. And null hypothesis here would be mean is equal to 20, and alternate would be mean is not equal to 20, because values given here are like this, because manager believes that it is 20, but actually it is being 22. So the manager belief is being taken as the null hypothesis, and the actual value which we have got would be taken as alternate hypothesis. So we'll be taking it as like one is equal to 20 and another one is not equal to 20. Right? So this is our null hypothesis, which states that mean is equal to 20, and alternate hypothesis, which is actually the hypothesis which we need to accept, basically, which we need to prove. So that is mu is not equal to 20, the manager's perception. Here's the formulas, and after applying, after putting all the values in the formulas, you'll be getting the values. And if it comes out to be within the critical regions, then that means your hypothesis, your null hypothesis would be rejected. That means the actual value which we have got as alternate hypothesis is true. That means mean would be assumed as not equal to 20. Another example, the researcher desired a 95% confidence and the significance level becomes 0.05 in that case. The researcher must then find the upper and lower limits of confidence interval to determine the region of rejection. Thus, the value of t is needed for that. For 24 degrees of freedom, that means n minus 1, 25 minus 1, the t value is this. This is again given in the tables of the textbook. Then lower limit would be again by using the formula as per this particular example which we have discussed till now. You will be calculating lower limit and upper limits, and then you will be checking whether it is coming under that particular critical region or not. Right? Then another one is chi-square test. This was all about t-test. T-test is basically done for smaller sample size, and when your sample follows a normal t distribution, bell-shaped, mean is 0 and standard deviation 1. For that, you will be using t-test. And if sample size is greater than 30, then you can either go with t or z-test. Testing a hypothesis about a distribution now. How would you distribute the sample? Using chi-square test. This is basically test for significance in the analysis of frequency distributions, and you will be comparing observed frequencies with expected frequencies. Like in the previous example, observed frequency was mean was equal to 22 for that factory, and because manager assumed it to be 20, so that would be considered as the expected frequency. So this way you will be comparing these two values in case of chi-square test, and this is also known as goodness of fit. Chi-square is generally known as goodness of fit. Sometimes question comes in and it would ask you for the goodness of fit rather than asking about the chi-square test. So you must know this is another name for chi-square test. Here's the formula. This is the simplest formula for univariate test. Your x square would be equal to summation of OI minus EI. OI means your observed values, E means expected values, the whole square divided by EI. Let us see it. I have put in the values like this as well, like so that you can go back later to check the PPT as well. Chi-square statistics. This is your chi-square statistics, and this is your observed value, observed frequency in the ith cell, and this is your expected value, expected frequency on the ith cell. So these three things are needed, and this is the simplest formula ever. Then estimation for expected number of each cell. Estimations for expected number. That means you will be checking this particular value here. You will be calculating this, right? So again, there is another formula. EIJ is equal to RICJ. divided by n. That means you are talking about rows and columns here. Let's see. Ri is total observed frequency in the ith row, and Cj is total observed frequency in the jth column, and whereas n is your sample size, right? This is very easy to remember formula because you are just talking about rows and columns here divided by the number of sample. Then univariate hypothesis test using chi-square. Let us see it with the help of one example. X square is equal to, again, observed value minus expected value ka whole square divided by expected value for 1 plus the same observed value for second cell minus expected value, the whole square divided by expected value for the second one, right? If this is in case of 2 entries, and you will be, it is the easiest one. Sometimes numerical also comes on chi-square test. You can put in the values if you have any example with you, and you can calculate it, right? You'll be getting the chi-square values for this, and again this with the help of same formulation you can calculate upper limits and lower limits for this, and you can calculate whether the test is significant or not. That's it. Let us discuss some true false now. Number 1, the scale of measurement used by the researcher determines the allowable statistical techniques in the research study. Is it? We just discussed three things to consider. One was your kind of questions you have, then number of variables, and then scale of measurement. So this is one of them. Scale of measurement used by the researcher determines the allowable statistical technique in the research study. Yes, this done. This is this actually does it with the help of whether the scale of measurement was parametric or non-parametric. So it is true. Second is, two major groupings of statistical procedures are parametric statistics and non-parametric statistics. Is it? Yes, when we talk about statistical procedure, we actually name them as parametric statistic and non-parametric statistic. Parametric statistics are used for the data who are metric in nature. Metric means we are talking about ratio scales here. We are talking about actual numbers here. And non-parametric tests would be used for those values which are collected either through nominal or ordinal scales. So it is true. Third is, parametric statistics are based on the assumption that the data in the study are drawn from a population with a normal distribution or normal sampling distribution. Yes, when we talk about parametric statistics, this is one of the assumptions we go for. Like your data should be distributed normally in a normal bell shaped. When we discussed it in the case of t-test is considered as a parametric statistic, and we used three things. We used three assumptions for t-test, and this was one among them, that your population with a normal distribution or a normal sampling distribution. So it is again true. Whenever you are going to decide whether you are going for parametric or non-parametric test, this is one of the foremost conditions, that your data should be normally distributed. Fourth is, non-parametric statistical tests are frequently referred to as distribution free. Is it? When we talk about non-parametrical statistical tests, yes, we do not care about how they are distributed, right? So we can actually call them as distribution free. That it doesn't matter whether they are distributed normally or not. So it is true. Nominal scales. Fifth is, nominal scales typically use parametric statistical tests. Nominal scales are those which are just numbered just like that. So these are the most common form of non-parametric test, right? So that means it is false. Sixth is, a univariate p-test. Univariate p-test is appropriate for testing hypothesis involving some observed mean against some specific value. Is there any univariate p-test? There is no p-test here, and it is the way definition is given, it is actually the definition of t-test. It is t-test is appropriate for testing hypothesis involving some observed mean against some specified value. So it is false. P value we take up for for checking the significance level, but when we talk about this test, it is t-test. Seventh is the t-test is strictly appropriate for tests involving small sample size with unknown standard deviations. Yes, t-test is generally done for small sample sizes. When your sample size tend to be to be more than 30, then you can go with either T or Z test. So it is true. Last is the logic behind the chi-square test is to compare the observed frequencies with the expected frequencies in the data set. Yes, if you remember the formula we have just discussed, chi-square is all about comparing observed frequencies with the expected frequencies. So this is true. Let us discuss some questions now. Number 1, list the factors to consider when choosing the appropriate statistical technique. Yes, this was the very first thing we discussed in this particular presentation, and these are the type of questions to be answered. For example, whether you want to check comparison between two variables, two or more variables, whether you want to check the association of variables among each other, or whether you just want to check whether the population is normally distributed or not. So many things are there, but kind of the questions, research questions you have in your study would decide what kind of the test, which one of the test you will be going for. Then second is how many variables you have in your study. If you have just one variable for the study, you will be going for univariate test. If you have two variables, you will go with bivariate test, and if you have more than two variables in the study, you will be going with multivariate analysis. Then third is whether your data is parametric or non-parametric, but kind of the scale measurement is involved in the study. The way you have collected data also defines which kind of the test you will be going through, whether they are collected on the basis of nominal or ordinal scale, or on the ratio scale, interval scale, right? So this would decide whether you will be going for parametric test or you will be going for non-parametric test. There are the test, like for the same kind of study, for the same kind of question, you will be having one parametric test if you have your data is collected on the basis of metric scale. And for the same kind of the study, for the similar data, if you have collected that data on the basis of nominal scale, you will be having one non-parametric test in against that particular parametric test, right? So we have all the tests available. It is just that the way you have collected data would define which would fit the best for your study. If you have used nominal scale data for the observation for the analysis to be done through parametric test, it would distort the result. It might not give you anything. It might tell you that your test is not statistically significant or something like that, or if even if it give you the results, it would be distorted. It would be of no use even if you use it in the study. So it is very important to check whether what kind of the questions you have in the study, then how many variables you have in the study, and then how did you collect the data so as to decide whether you will be going for parametric or non-parametric test. Then second is compare and contrast parametric statistics with non-parametric statistics. How would you compare them? Parametric statistics involve numbers, right, with known and continuous distributions when the data are interval or ratio and the sample size is large. Parametric statistical procedures are appropriate in case of these things only: when sample size is large, plus when you have collected data on the basis of either interval or ratio scale. But when it comes to non-parametric statistics, these are appropriate when the numbers do not conform to a non-distribution, making the assumption that the population distribution or sampling distribution is normal generally is inappropriate when the data are either ordinal or nominal. So in case of non-parametric test, We do not assume that we will be having normal distribution of the data. No, we do not go with this assumption. If you have collected data with the help of nominal or ordinal scale, you will simply go with non-parametric test. Or if you have collected data with the help of interval or ratio scale, then you will be going with parametric test. But before that, you will be checking whether the data is normally distributed or not. Last is describe the chi-square test for goodness of fit and explain when it is the appropriate test. See here, both the things are mentioned, chi-square test as well as goodness of fit. But sometimes you get questions like whether where either this particular thing, chi-square test, is mentioned or goodness of fit is mentioned. You have to understand that they are talking about chi-square test. Chi-square test is one of the most basic tests for statistical significance and is particularly appropriate for testing hypotheses about frequencies arranged in a frequency or contingency table. Univariate test involving nominal or ordinal values are examined with the contingency, or you can say with the with the goodness of fit or with the chi-square test. More generally, this test is associated with your goodness of fit, which talks about your expected values and your observed values. We call them as expected frequency and observed frequency, right? Most often the test is between a table of observed frequency counts and another table of expected values for those counts, right? Chi-square is the appropriate way for testing whether the values in one way frequency tables are different than would be expected by chance. Like we discussed the example of manager thinking that the defective units are 20, but in actual observation for that was 22. In that case, chi-square test would be the best one. That's it. In our next presentation, we will be discussing bivariate analysis. Univariate analysis is one when we had just one variable for the analysis, right? Or you can say you might be having 10 variables, 20 variables in the study, but now you want to check, you want to discuss, or you want to analyze just one variable at a time, then you will be going with univariate statistic. But when you talk about two variables at one time, when you try to analyze two variables at one time all together, then you will be going with bivariate analysis. Bivariate analysis also consists of a t-test. So that is why when it comes to univariate statistic, and that t-test is known as student's t-distribution. And when we'll be going for t-test in bivariate analysis, we'll be calling it as a t-distribution, t-test. Bivariate analysis would also be further bifurcated in 2-3 types, whether you will be going for test of differences or you will be checking the association among the variables. This is another thing. So bivariate analysis would be bifurcated in 2 presentations. One would be discussing with you test of differences, what kind of the differences we have in the variable or in their categories, and another would be checking the association of 2 variables with each other. Right? Thank you.